heads up, looking at my screen. Right, this first one, you can see it is a positive gradient, therefore I'm going to have a positive number in front of the x. It is going to cross at 5. So if I look, that is a potential because it's plus 5. Let's just have a check. There are no other plus 5s. All right, so therefore I know that is the correct answer, but also just checking, look, if I start with a point, I go across 1, I go up 2, therefore it's 2x. Right, this next one is another positive. It crosses at 1, therefore my options are x plus 1, 2x plus 1, nothing else. Okay, no, none of the others. So this is how we were doing this task. It's not that one. So which one is it? Well, if it was x plus 1, it would be going across 1 up 1, and it's not. It's going across 1 up 2, so therefore it's 2x plus 1. All right. Now, this final one I'm going to talk about crosses at 4. So again, I need ones where the c is 4. Now I can see that this one, look, has a 4 and it's not multiplied by x. So that's my c. All right. I have no others. Therefore, that one has to be it. But let's just check. It is a run of 2 and a drop of 1. So it's negative 1 over 2. So that's why that one is the correct answer for that particular one. So going through it, and the ones that you have done, that's kind of like your thought processes. So I have been seeing people that have been doing, well, does this work? And this number here, the plus c, does not match. That's really your first choice. Okay? Make sense? Right. Can we get your notebooks back out, please? Because I want to have a look at these questions. That was merely one thing that we have to do. Hopefully this copies and pastes all right. Why is it not doing it? Also, so we've already discovered that if we've got the line in front of us and we can see that it goes through the y-axis where it is, we can easily find the gradient that y equals mx plus c is definitely the easiest form. But what if we're not given a graph? What if we're just given some other information? All right. So if we're given it in word form, so thinking about your assessment, these are kind of the other things we're going to be doing. So if I've got a line with a slope of negative 4 and a y-intercept of 5, which form is the best way to write it? Y equals mx plus c. Okay? Because the slope is the m and the y-intercept is the c. So for A is just y equals
negative 4x
plus 5. Okay? All right. So that's an example. I'm going to do that one. Right? Is B any different? Yes. What's different about B? So we've got the slope, which is m, but this point is not the plus c. 2, 3 is not the plus c. So given this information, I could work it out, but why bother when I've got another form to use? So for B, I would, in this case, use the point slope form, like you were just saying. So we can say y minus 3 equals 1/3 of x minus 2. Okay. Which I can change to mx plus c if I want by doing 1/3 of x minus 2/3. So that's the expansion. And then I need to test my ability to add with fractions. If we add 3 to both sides, we get y equals 1/3 x, or minus 2/3 plus 3. Well, is it going to be a polygon? So we're going to add 2 and 1/3. Yeah? Now, can you imagine trying to spot that y-axis intercept on the graph at 2 and 1/3? It's not going to be the easiest one to do, is it? Okay? So you can see how that was definitely the easier way to do it. So even if I had that line drawn in front of me on the paper, it probably wouldn't have been the easiest one, that mx plus c wouldn't have been the easiest route to take. Okay, interesting. Next one. What about the line with a slope of -2 and an x-intercept of 5? Why? Just because we haven't used it yet.
Yeah.
I wouldn't go with that. Isn't the x-intercept just another point? Yeah, the one we just did. What is the x-intercept? What's the coordinates?
5, 0.
Good. So that was that assessment we did where we know that the y-coordinate of the x-intercept is 0. So now we just do y minus 0. So that's nice.
-2
Equals -2x,
minus 5.
which is nice because we can turn it straight into -2x plus 10. So mx plus c comes nice and easy for that. Right. Now, D.
No.
That would be, did you do y minus y equals m x minus x? Because that is the coordinate.
Yeah, it does have coordinate, definitely. But when that is point slope form, yeah? That's one coordinate and slope needed. But mx plus c is slope and the y-axis needed. Ax plus by equals c, and I don't even know. Do I need a point? Do I need a slope? So really, we are going to still be using either mx plus c or point slope. This case, there's just an extra amount of working to do. What is it?
You just have to find like the distance between them.
Yeah, so we've just got to find m first before we make a decision. Remember how to do that?
Yeah.
No.
Do you remember m is rise over run, so it's y2 minus
Would be
y1 over x2 minus x1. Do you remember saying it doesn't actually matter which way round you do it as long as you're consistent? So in these two coordinates, this is x1, y1, x2, y2. So m is
5 over
3 minus 2 over
1.
4 minus 6, which turns into 3 plus 2 is
5.
5, 4 plus 6 is 10. So actually we've got a half. So m is 1 over 2. There's the slope. Now what do we do? Which form should we use?
Probably point slope because we don't have the initial condition.
Exactly. We haven't got the y-axis intercept. We've got 2 points. Which one should I use? Doesn't matter. Good. Good answer. Right, so let's do that then. Let's say y minus, which coordinate should we use? 4, 3?
Sure.
Okay.
I like
Y minus 3 equals
1/2
1/2
times
x minus
4.
4. So that's half x. What's a half times minus 4?
2. Or negative.
Negative 2, good. We've got y, so now we've got to add the 3 on, and we end up with y equals 1/2 x
Plus 1.
plus 1. Okay,
Hooray.
so we just had to do the slope first. Which form have I not used at all then? The standard form. So that standard form is useful for when we're drawing graphs, but not necessarily useful for when we want to know the equation of the graph.